Good morning.
Good morning.
Okay. All right. So today is review day, right? We're looking at test 2. So you have until Thursday to take the test. I don't know. I think maybe one person's taken it so far, possibly. And I think you're all aware that the extra credit is going to be due by 11:59 p.m. tonight. So we'll see how that goes. Now, test 2 is pretty big as far as material goes. I don't think we probably wouldn't get through it in a class session like we're going to do today. So what I'll do is I'll try and focus on the ones that people seem to have the most problems with or want to talk about. Does anybody have any specific ones that they would like to talk about? Any questions?
Hey, Professor.
Yes, Gabrielle.
I'm confused on the buffer regions for question 1.
Okay. Now, just for your own knowledge, actually, what I'll do is I will open up another instance of my courses here. I'll show you something. Okay, here's what we're looking at. Let's see. All right, mini lectures. When will buffering be shown on a titration curve? So there's a video about this, Gabrielle, too. You can take a look at that as well after I've talked about it here, if you're still a little bit concerned about it. Okay, let's talk about when you're going to see a buffer region, when you're not going to see a buffer region. Now, if we remember what a buffer is, so we get a buffer region. It's a bit slow right now. It'll speed up in a minute, I'm sure. I'll close that down and reopen it, see if that helps. Okay, let's see if that helps. Okay, there it goes better. So we get buffers. The definition of buffer is a mixture of a weak acid and its conjugate base that resists changes in pH on addition of strong acid or base. Now the buffer region itself turns up as what amounts to a straight line on the pH curve here. So that would be the buffer region. Now that's not necessary, you won't necessarily see it as straight though. But on all these curves, the buffer region is marked anyway. So what's happening here is that you've got the pH on the y-axis, and there's not much of a change in pH upon addition of strong acid or base. So this is always going to be volume of strong acid or base, because that's the definition of a buffer region, is that it's a mixture of a weak acid and its conjugate base that results in that resists changes in pH on addition of strong acid or base. So that's really the important part here, which makes it here is always going to be volume of strong acid or base. So those are the two ingredients you need, Gabrielle. You need to be adding a strong acid or base, and it needs to be a weak acid that's being asked about in the question. So that in that instance, you'll always have a buffer region, and it will always be at the beginning. It could look like that, or it could look like this. And again, it's always going to be volume of a strong acid or base down here. Do you have any questions? Is that okay, Gabrielle?
Yeah, that's good. Thank you.
All right. Does anybody have any other questions that they want to ask about for test 2? And it's your time, folks. I'm not here for my pleasure. I'm here for yours. Does anybody have any other questions that they want to ask about for test 2? Can you go over buffer problems? Okay. So what I'm going to do, Kate, is I'm going to go over problem 16 through 19. Okay. So let's look at 16 first. Okay. I'll draw this out in pictures first. So it says here, buffer is made up of equal volumes. And we'll show those equal volumes in a minute, but equal volumes, it says, are 226.5 mils each. Okay. Of 0.701 molar AH. And 0.873 molar A minus. And we're going to add sodium hydroxide. And it looks like 12.34 mils of NaOH. So these are joined together So our total volume is going to be something different, but we'll get to that in a minute. I don't know if we actually, I'm not even sure we need that for this problem. Because I think all we're interested in is how many moles of AH are going to be present after the reaction has occurred. But yes, if we were to put it together, it would be double that volume. And what we're doing is we're adding the sodium hydroxide to that mixture, that buffer mixture right there. That's why I drew it out. So what's the sodium hydroxide going to interact with? Well, sodium hydroxide is OH minus. So it's not going to interact with the A minus, it's going to interact with the AH. So the AH will react with the OH minus, or at least some of it will, to form A minus and H2O. The net effect of that is that the AH is going to go down and the A minus is going to go up. Because we've already got a whole bunch of AH and A minus in there, and then all we're doing is creating more of it by reacting it with OH minus. So what we're interested in here is how many moles of AH are present. So the AH is going to go down. How much is it going to go down by? Well, it's going to go down by the amount of OH minus that we add. So first of all, we find the initial moles of AH, which is going to be 0.701 moles per liter times 0.2265 liters. And if let's open up the calculator here. We get 0.159 moles. And we also need to see how many moles of OH minus we're adding. We'll say initial moles of OH minus, which is going to be 0.187 times 0.01234 liters. And I get 0.00231 moles of sodium hydroxide. So that's the thing. I mean, if you've got 0.00231 moles of this, that's how many moles of AH it will react with. So that's why we're going to subtract 0.00231 from 0.159. That'll give us the amount or number of moles of AH left over. So the final AH is going to equal the initial AH, initial moles of AH, minus the initial moles of OH minus. Which in this instance is going to equal, with significant figures, 0.157. So that would be the final answer. Does anybody have any questions? The main thing with these questions is knowing that when you've got a buffer solution that contains A minus and AH, and you add OH minus, the OH minus reacts only with the AH. turning into A minus and H2O, meaning the AH goes up. Sorry, the AH goes down and the A minus goes up. In the situation where you're adding H plus to the same buffer solution, the H plus will react only with the A minus, turning into AH, and the A minus will go down and the AH will go up. So it's about whether you add or subtract that's going to be the issue there. Does anybody have any questions? All right. So for this one, again, we're adding sodium hydroxide, and we're looking for this time moles of A minus that we're going to get from this. Now, just drawing the situation here, I'm not going to draw the whole thing out, just part of it. Again, we're adding OH minus into the solution of AH and A minus. So the AH will react with the OH minus and form A minus and H2O. So I know the AH goes down and the A minus goes up. Now the initial A minus here is going to be 617.1 is going to be the volume. So let's see, was it 0.740 moles per liter? And that's times 0.6171 liters. And that's going to be 0.457 moles. And then we've got the sodium hydroxide here. Which is going to be 20.11 mils and 0.104 moles per liter. Zero. .0211. No. 0.02011 liters. Okay, it's 0.002 0.09 moles. So the final moles of A minus is going to equal the initial moles of A minus plus the initial moles of OH minus. So that's going to be 0.457 plus 0.00209 moles, which is going to be 0.459. The plus is important here. All right, does anybody have any questions about that? Kate, since you're the one who asked, did you have any questions about 16 or 17 about why it's minus or plus?
No, after you showed the equation of how they reacted, I understood.
Okay. Now the table here, I'm going to leave that to you all to figure out. I'm not going to go through that. It's the same answer for everything, so you have to figure out what that answer is. And number 19, I'll go through that one. So we've got a buffer made up of equal volumes of AH and A-. What's the pH of the buffer after addition of, in this case, sodium hydroxide? So for this one, what you'll have to do is figure out the initial moles of AH and A-. So we'll do that first. So we'll do the AH first. And we'll do the A-. Now the AH is going to be, let's see, we've got 0.630 mole. That's times the volume, which is 0.3180 litres, which comes out to be 0.200 moles. For the A-, we've got 0.664 times again the 318 in litres. So 0.664 times 0.318. Okay, so that'd be 0.211 moles. And we're also going to get the OH- here as well. And that's going to be, let's see, 0.126 times 10.09. And that's going to be 0.00137. In the next step, we're looking at the reaction moles. And what we know is that since we're reacting with OH-, it's the same reaction as we were looking at just a couple of minutes ago. So we know that it's going to be AH plus O- gives A- plus H2O. We know that the AH is going down, the A- is going up. So the reaction moles, we're looking at, let's see, so it'll be the initial moles of, for AH, it'll be initial moles of AH minus the moles of the initial moles of OH-. And that's going to be 0.200 moles minus 0.00137 moles. Now per significant figures, that's going to be 0.259 moles. For the A-, it'll be initial moles of A- plus moles, initial moles of OH-, which is going to be 0.211 moles plus 0.00137 moles. Which is 0.212. Does anybody have any questions so far? We're not done yet. The next step here is to figure out the concentrations. So the concentration of AH and A minus. So the concentration of AH is going to equal the moles of AH over the total volume in liters. So 0.260 and hang on, let me take a look. I did, didn't I? All right. So thanks, Max. So 0.200. I don't know where I got the 0.260 from. All right, I'll correct that. Thank you. Yeah, I don't know where I got that from. I must have misread it or something. So it'd be 0.199 moles down here. Okay, thank you. So the concentration of AH then will be 0.199 moles over the total volume in liters. Now, total volume is going to be, let's have a look, 318 times 2, which is 636, plus the 10.09, which would be, let's see, 636 points. Now let's have a look. I know I'm going to have to account for significant figures here as well. Okay, so it'd be 646.1 is what the total volume is going to be. So it's both of those components plus the sodium hydroxide. Okay. Okay, 0.308 moles per liter. And for the A minus, it'll be moles of A minus divided by the total volume in liters, which would be 0.212 moles divided by 0.6461 liters. And that would be 0.328 molar. This next part you probably really don't have to do, but it helps with the understanding of what's going on. Move this over a little bit. So the reaction that we're looking at now, but we're in the buffer solution, is this equilibrium. And we have figures for this. We have 0.308, we have 0.328, and at the beginning of the equilibrium we have no H plus in solution. But then after a time, it'll be 0.308 minus Z, 0.328 plus Z, and Z. Now, since it's a weak acid, Now remember, this table is going to be the same regardless of whether we add strong acid or strong base. In this case, we added strong base, but that doesn't change the fact this is going to be minus, this is going to be plus. Because this is after the addition of strong acid or strong base. Any strong acid or strong base that's been added is already gone. We're talking just about the equilibrium of the remaining solution. So it's a weak acid, so we're going to assume. Does anybody have any questions about that? I hope you understood what I just said. It's important. Okay. Now remember, this is a buffer solution. I don't have to validate this assumption that I'm making here. So that's what we're getting there. Now the Ka is going to equal A minus times H plus over AH. Now the Ka value is given in the problem. Let's see, what is it? 4.650 times 10 to the negative 5. The A minus is 0.328 times the H plus over 0.308. Then we can solve for the concentration of H plus from that. So it'd be 4.65 times 10 to the negative 5 times 0.308 divided by 0.328. And if that's our 4.36 times 10 to the negative 5, and the pH then is going to be the negative log of that, so take the log, and it comes out to be 4.359 or 4.360. And that would be the final answer there. Does anybody have any questions? So that would be the answer. That would be the final pH. Anybody have any questions? Okay. Anybody have any other questions they want to ask about the test? Any other questions you want to ask about the test? Can you go over again why we would subtract her out? Okay. Okay, I'm going to go over two cases here, Karen. Both possible cases that you would see here. So we start off with a buffer which is going to be a mixture of A minus and AH. And we add to that, we'll add OH minus on the first one. But I'm only going to add one OH minus. And in the case of the other one, it's going to be the same buffer. And this time I'm going to add H plus. And it's just 1 by H plus that I'm adding here. So the reaction that we're going to see in the first instance will be A minus, sorry, not A minus, be AH plus OH minus gives A minus plus H2O. And what's going to happen there is only one of those AHs is going to react, and we're going to be left with A minus, A minus, A minus, and AH. So what you can see there is that the A minus has gone up by 1, and the AH has gone down by 1. Karen, do you see that?
Yeah.
Okay, so it's for the 1 by AH being added, it's reacting with the A minus. The reverse happens. We'll end up with 3 AHs, 1 A minus. So the AH has gone up by 1, and the A minus has gone down by 1. So what happens here is that when we're looking at the reaction moles, for AH, it's going to be initial AH minus initial OH minus. And for A minus, it's going to be initial A minus plus initial OH minus. On the other side, again, reaction moles, it'll be for AH, it'll be initial AH plus initial H plus, and for A minus, it's going to be initial A minus minus initial H plus. All right, does anybody have any questions? So Karen, did you have any other questions about that since you asked the question?
No, that's good. Thank you.
All right, thanks. All right, does anybody have any other questions that they want to ask? Anybody have any other questions they want to ask? Solubility and Ksp. Okay. So I'll go over these problems here, 20 through 24, Emmeline. Okay. So let's look at how we break stuff up first. So this one is asking for SN3PO4 4. How's that break apart? So draw a picture of it. PO4 is 3 negative, and I get that from down here in the list. And that means it's a negative 12, which means this is positive 12, which means each of these has to be 4 plus. So when I'm writing it out, it would be 3 SN 4 plus 4 PO4 3 minus would be the answer there. Does anybody have any questions so far? Okay. SNBR4 is going to be 1 SN and then 4 BRs. Which is going to be negative 4. That's going to be positive 4 on the 10. So it'll be SN 4 plus 4 BR minus is what you have to write there. Does anybody have any questions about that one? Okay, let's see if there's another one here. I'm going to come up with another one on my own here. CRPO4. And I know I've talked about this before, but I'm going to talk about it again. Yeah, with SNBR4, you can see there are 4 bromines. With CRPO4, you have to realize there's 1 CR and only 1 PO4 unit there, which would make it PO4 3 minus and CR3 plus. So that would be CR3 plus PO4 3 minus. These other ones are just done pretty much the same way as what I've just done there. But I'll go through it anyway. CRBR2. CRBR2. Whoops. Minus on the bromines, plus 2 on the chromium. CR2 plus 2 BR minus is what you'd write down there. Any questions? Here's another one here I missed out on. CR2S3. S. S is negative 2 because it's in group 6. Positive 6 on the CRs to match the negative 6 on the S's. CR3 plus 2 CR3 plus 3S 2 minus. Yeah. Okay. Does anybody have any questions about number 22? Emmeline, how are you doing so far?
So far, I'm starting to understand where I'm making my errors on these questions.
The breaking up part. Did you want to do more of these?
Just a couple more because I'm thinking I'm understanding where I went wrong and why my calculations weren't quite correct.
Okay, I'm going to re-roll this. We'll come up with some others. I like this one, Cu2O. So it's Cu, Cu, and O. O is -2 because it's in group 6, which makes the coppers +2, which means they have to be +1 each. 2 Cu plus O2 minus. Any questions about that one? Okay. SnCN4. Negative, 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 negative. That's -4. +4 on the tin. So that's going to be, let's see, SN4 plus 4CN minus. Any questions about that one? CRBR3. We did CRBR2 earlier. This will be a little different. Negative, negative, negative on the bromines, -3, +3, 3 plus on the chromium, Cr3 plus 3 Br minus. Any questions? Okay, the last one here, Cu3PO4. I really like this one. That's 3 Cus, 1 PO4. PO4 is 3 negative, it's -3, +3, positive, positive, positive on the coppers. 3 Cu, 1 plus, plus PO4, 3 minus. Any questions about that? That one is a really good one, that last one. All right, Emmeline, how are you looking here?
I'm doing a lot better now because now I realize I wasn't correctly looking at the periodic table right to also fill in the plus and the minuses on it either.
Okay, well, good. All right. So keep on, well, the advice I have for you then, Emmeline, is to keep on doing this. Keep on doing this ungraded copy and, keep on doing those examples and making sure that you're checking your answers against the answers that they're supposed to be.
Okay, will do.
All right, I will continue here and look at question 24. Oh yeah, that's all right. This one's an all right one. Okay. So a slightly soluble salt has a formula AB5. And that's going to break apart into A and 5Bs. You don't really need to worry about the charges, but I'll put some charges on just for kicks anyway. They're not really that important though. So initially, that's a solid. There's no molarity on the solid. And we'll have 0 and 0 on the ions. And then there's no molarity at equilibrium for the solid either. But this will be Z and this will be 5Z. So we've got Ksp is going to equal A5 plus and B minus to the power of 5. Ksp value 7.1 times 10 to the negative 32. And that's going to be Z times 5Z to the 5th. And then we have to solve for Z. So 7.1 times 10 to the negative 32 is equal to Z times, I think it's 3125 times Z to the 5th, which means it's going to be 7.1 times 10 to the negative 32 is equal to 3125 times Z to the 6th. z is going to equal the sixth root of 7.1 times 10 to the negative 32 divided by 3125. So when we're doing that sixth root, we can do to the power of 1/6. Or you can use your calculator to figure it out using the root button as well. For this one, let's clear it out. 7.1 times 10 to the negative 32. Sorry about that. Divided by 3125. Okay, so I can do this to the power of 1/6, or I can take the sixth root. So I can do this x and then 6, and that'll give me the correct answer, which is 1.68 times 10 to the negative 6, or 1.7 times 10 to the negative 6 molar. I'll show you the other way of doing this, and that would be 7.1, oops, clear it out, 7.1 negative 32 divided by 3125, and then to the power, where are we, x to the y, here we go, to the power of 1 divided by 6. And that gives me the same answer. Does anybody have any questions? Okay, so that's Z. Now, if you look at what it's being asked for here is PB. And that's not lead, by the way. It's the negative log of the concentration of B, but B is actually 5Z. So concentration of B minus is equal to 5Z. And a lot of people forget this step, times 1.7 times 10 to the negative 6. So where's my thing here? So times 5. And then I take the log of that. Oh, that'd be 8. Let's just do that. That's 8.41 times 10 to the negative 6, or 8.4 times 10 to the negative 6. And then PB is going to equal, take the log of that, 5.07. And that'd be the answer you'd put in. Okay, does anybody have any questions? Emmeline, since you asked about this, how do you feel about that?
I feel more better, especially since you showed how to do it on the calculator, because I was having issues typing my calculator correctly to get the correct answer.
It's going to vary from calculator to calculator though. But you know, most calculators do have an X to the Y button and an X and a root, some sort of root button as well, like a Y root X button too. But I think the easiest way is to do it to the power of 1 over what you're doing to get the root. I think that's universally, that's probably the easier way of doing it.
Okay.
All right, does anybody have any other questions about this? Okay, just another reminder here about doing the test. So when you do it, you know, I am expecting you, if you want partial credit, or you want the possibility of partial credit, you will have to show your work in the box at the bottom. So I have provided you some extra time on the test to do that, so that you can type in your work at the bottom. A lot of students feel resentful about having to do that. They feel like, well, you know, I've got my scratch paper, I should just be able to scan that in somewhere. But you see, the thing is that it's too easy for somebody to get the results on the test, go back, fix up their scratch paper, and then submit that to me for partial credit. And I just don't want to go down that road. So the only solution that I can see that's reasonable is for you to type in your work down the bottom, so I have it there in real time. I know exactly what you did under honor lock and how you did it. So that's the only way I can really have true security, at least in my eyes, is by having you do the work in the bottom box there. Now, if you don't want the possibility of partial credit, you don't have to do it. You don't have to do it. But I know what's going to happen is you're going to get a question wrong, and then you're going to be emailing me saying, well, look, I know I did it right. Can I have, well, no, not if you need, that's why you need to type in the work. Does anybody have any questions? Okay, does anybody have any other questions they want to ask about the test? Any other questions about the test? Going once, going twice, going 3 times. All right. Okay, well then, you got your work cut out for you. You know what you need to do. I know many of you haven't even started yet on the review. That's going to be problematic. It's a lot of material here to get over in 2 days or a day and a half or whatever you've got set aside for it, or 3 minutes or whatever. But you're going to have to, you're going to have to make sure you know everything. That's the thing. Nobody can come back at me and say I haven't given you all the resources, nor can you say I didn't give you the time to get through the material that needed to get done. So it's up to you now to deal with any shortage of time you might have at this point. All right, well, I guess that's it. I'll see you all. Well, I did send you an email. I said that there won't be a class on Thursday after we come back from spring break, but we'll have a class on Tuesday though. And I'll see you all after spring break. So have a good spring break, everybody. And I will catch you Tuesday after spring break.
Thank you, Professor.
Thanks, Karen.